This video looks at mixed circuits. And a mixed circuit is a circuit where some of the components are in series and other components are in parallel. And a super quick review, in a series circuit, the current is always the same. So the current through both of these light bulbs are going to be the same because they are in series. To calculate the voltage through each light bulb, you would use Ohm's law, because we know the current is the same, and in the problem they'll tell you the voltage. And then to calculate the equivalent resistance, or the total resistance of these two guys together, we'd use this equation, and that is how it's given on the AP test. And it just says resistors in series, the equivalent resistor is just sum of all the resistors. So just add them up, however many you've got. And then for a parallel circuit, that's going to be like these guys. So together, these guys are in series, but then this series and this series, they're in parallel with each other, because right here, the current had options of where it was going to go. And options means parallel. And when you're in parallel, the voltage is the same. So the voltage then from here to here is the same as the voltage from here to there, because these guys are in parallel. To calculate the current through each path, again, you're going to have to use Ohm's law. This is Ohm's law, and I've rearranged it to solve for current, and get current is voltage divided by resistance, and this is how Ohm's law appears on the AP test. And then if we wanted to put these guys together to get one total equivalent resistor, we would do this, and that is basically saying 1 over Req when you're in parallel is equal to 1 over each of your resistors added together with however many you have. And this is how that is shown on the AP test. So let's give it a try. So here we have our first circuit, and here the current in the battery, or the voltage of the battery, sorry, is going to be 120 volts. And we want to analyze this circuit. So they want us to figure out the total resistance of all these 4 resistors, the current through each resistor, and the voltage through each resistor. And then over here in the table, they tell us the resistances of each of these resistors. So R1 is 16 ohms. R2 is also 16 ohms. R3 and R4 are both 32 ohms. Okay, so looking at this, I notice as the current comes out of the battery, it has to go through R1. So R1 is going to be getting the total current. But then when it gets to this junction right here, it's going to split. And some is going to go through R2, some through R3, and some through R4. But the currents in these 3 are not going to be the same, because some of them have larger resistances than others. So R2 is going to get more current than R3 and 4 because R2 has a smaller resistance. But looking at these guys, because there's a junction and then there's an option for current, that means parallel. So these guys are in parallel with each other, and when you're in parallel, the voltage is the same. So looking at these guys, R2, R3, and R4, they're all going to have the same voltage, but it's not 120 volts because R1 is going to be sharing this 120 volts with whatever this total resistance is. So step 1, whenever you're trying to do anything with a mixed circuit, the first thing you want to do is figure out the total resistance. So we want to reduce this down to one total equivalent resistor. So doing that, the first step, I'm going to look at these guys. So these guys, I can tell they are in parallel. And when you're in parallel, to get that total resistor, instead of calling that REQ or R total, I'm going to call it, because we're putting together resistor 2, 3, and 4, I'm going to call it R2, 3, 4, so I can kind of tell where it came from. And that's going to be equal to 1 over 16 plus 1 over 32 plus 1 over 32. Let's see here. This is 32, 2 32s. That's going to get me 4 32s. So then I know 1 over R234 is equal to 4 32s, or 1/8. So now I know R234 is equal to 8 ohms. So that means I could redraw this whole thing. Let's see, I'm redrawing it over here. I could redraw this whole thing. We've got a battery, resistor 1, and then resistor 234. And here we have resistor 1 again, 16 ohms. And then we also have resistor 234, and this guy is 8 ohms. And our battery is still 120 volts. Now as I look at this, these guys are in series, so I'm going to put them together. Since these guys are in series, the current through these guys are going to be the same. So putting those guys together, so these guys are in series. So in series, putting them together, I'm going to call that resistor 1, 2, 3, 4. So that's going to be resistor 1 plus resistor 234 to get us a total resistance of 16 plus 8, 24 ohms. So that means I could redraw this whole thing as a battery, and then one total equivalent 24 ohm resistor. So let's see, what am I trying to do? So now I got the total, so I know our total is 24 ohms. So looking at the chart, let's see, I need to figure out, I know the resistance for these 4 resistors, I need the current for these 4, and the voltage for these 4. And I know my total resistance. So my total resistance ended up being 24, and I'm going to put that into my table to help just hold on my numbers. So my total is 24 ohms. The total voltage is always from the battery, and that's 120 volts. Ooh, at this point we could figure out the current. So my total current is going to be right here, this total current. And if I know my voltage, 120 volts, I know that current is equal to voltage divided by resistance. And if I have the total voltage, 120 volts, and my total resistance, 24 ohms, I can get my total current ends up being 5 amps. So now I know my total current is 5 amps. But looking at this, when I made this, I made that from a series circuit. And current is the same in a series circuit. So that means the current through these two is the same, and this is key, it's the same as the current through their total resistor. So putting these two together, I got 24 ohms, and if 24 ohms has 5 amps of current going through it, these two both also have 5 amps of current. So now I know resistor 1 has 5 amps of current going through it. I know resistor 234 also has 5 amps. That's not on my table. I might add it. So I'm going to add resistor 234 to my table. Maybe if I can write on here, 2, 3, 4 to the table. And I calculated resistor 234 has a resistance of 8 ohms, and we just figured out it has a current of 5 amps. Okay. Now looking back to R1, I know its resistance and I know its current, so I could figure out R1's voltage, because using our Vert equation, voltage is current times resistance. So getting this voltage here, I know, let's do that here maybe. I know that voltage is equal to current times resistance, and if I know the voltage through 1 and the current through 1 and the resistance through 1, I guess I could get the voltage. So looking at this, the current through 1 is 5 amps. The resistance of resistor 1 is 16 ohms. So then the voltage is 80 volts. So putting that up here, we've got 80 volts. Okay, so now what's left? We've got resistor 2, 3, and 4. These guys were the parallel ones. So I know their total resistance is 8, and their total current is 5. But if we look over here at this picture, it's 5 amps coming into this junction right here, and then it splits into 3 different paths, and it doesn't do so evenly because it's not the same resistance for each path. But let's see, I do know these guys are in parallel, so their voltage is going to be the same. So if their voltage is the same, that means the voltage for resistor 2 is the same as resistor 3, it's the same as resistor 4, and here's the really key part. It's also the same for their total resistor, and that total resistor is resistor 234. So that total resistor is this 8 ohm resistor. And we know the resistance of the 8 ohm, and over here we figured out the current through the 8 ohm. So we could easily figure out the voltage through the 8 or across the 8 ohm. So looking at this voltage, I know voltage is I times R, and I know I for the 8 ohm is 5 amps. I know resistance for the 8 ohms is 8 ohms. So then the voltage for the 8 ohm resistor is 40 volts. So this gets 40 volts across it, which means from here to here is 40 volts, which means resistor 2 is 40 volts, 3 is 40 volts, and 4 is 40 volts. So I know all of these. 40 volts, 40 volts, 40 volts. So now if I know resistance and voltage, I can easily figure out these currents. So let's do that down here maybe, because I know voltage is current times resistance, and we want current. So using this equation here, I know current is voltage divided by resistance. So if I'm doing current through 2, I'm using voltage of 2 and resistance of 2. So that's going to be 40 volts. And the resistance for resistor 2 is 16 ohms. So this gets me 2.5 amps. So this one is 2.5 amps. Looking at resistor 3, the current through 3 is again going to be 40. volts, but the resistance of resistor 3 is 32 ohms. So that's going to be 1.25 amps. So 1.25 amps. And then resistor 4 is the same as resistor 3. So that's also 1.25 amps. So there we go. We did it. So looking at the relationship in this circuit really quick that we just did, looking at the current first. So here we found that the total current was 5 amps. So that means 5 amps come out of the battery. 5 amps has to go through R1. But then at this point there's a junction. And according to Kirchhoff's junction rule, it's going to split. And so as it splits, if we look at this, if we add all these currents back up, we're going to get 5 amps of current. So then right here, when all those currents meet back up, again on this side, again we're at 5 amps of current coming back to the battery. Another thing to look at these currents is this resistor is half the resistor of resistor 3. And so because it has a smaller resistance, it's easier for the current to flow through resistor 2, so more current will flow through resistor 2. And because resistor 2 has half as much resistance as resistor 3 or resistor 4, it gets double the current. Then, looking at voltage, I know total voltage comes from the battery, and that's 120 volts. We found from here to here, this potential difference, or voltage, is 80 volts. So from there to there is 80 volts. That leaves us, if we have 120 total and we've already used 80, that leaves us 40 left. So then we found out from here to there is 40 volts. So going down either path, so the current has to go through this 16 ohm resistor, it has to go through this 80 volts of electric potential difference, but then it has a choice of paths it can take, but all paths then lead straight back to the battery. So at this point, your electrons still have 40 volts of electric potential. They need to lose that in order to get back to the battery. So each of these paths here have 40 volts of electric potential difference, and that allows your electron to lose all of it when it makes it back to the other side of the battery. So let's try one more example, and you should try this example on your own. I recommend pausing the video and giving this a try, and then watching the video if you get stuck. So step 1 in analyzing a circuit is going to be to calculate the total resistance. So as I look at this, I see this 20 ohm resistor is in parallel with our 12 volt battery, because we can go from the battery through this 20 ohm straight back to the other side of the battery. So let's see, I'm going to try and fill out as much of the table as I can. So looking at this, I'm going to call this resistor 1, and then resistor 2, and resistor 3. So resistor 1 is 20 ohms, and I can see it's in parallel with the battery. So it is getting all 12 volts from the battery. This is one closed loop here. So we already know the voltage for resistor 1 is 12 volts, same as the battery. Then, looking at resistor 2 and 3, these guys are in series, so they're going to have the same current. And together, resistor 2, 3 is going to have the same voltage as resistor 1 and as the battery, because it's in parallel. But let's see. I guess that's all I can figure out straight away. So now I'm going to put these two guys together. So I notice these guys are in series, and I want to put them together. So these guys are series, and with series, the total resistance, so I'm going to call that resistor 2, 3, is resistor 2 plus resistor 3. So 2 ohms plus 3 ohms gets me 5 ohms. I'm going to put that on my table here. I know we've got a 5 ohm resistor is resistor 2, 3, has a resistance of 5 ohms. So then I could redraw this circuit, and I would have, let's see, my battery. I would have resistor 1, 20 ohms, and I would have resistor 2, 3 at 5 ohms. So this is resistor 2, 3 at 5 ohms, and so resistor 2, 3, and I still have resistor 1 at 20 ohms. And we still have the battery at 12 volts. Ooh, so looking at this, I notice these guys are in parallel with each other and with the battery. So looking at this 5 ohm resistor, we have a closed loop right here. So this 5 ohm resistor must be getting all 12 volts from the battery. So I'm going to add that into the table. So my 5 ohm resistor is also getting all 12 volts from the battery. And now let's try and put these two together. So these guys, I notice they are in parallel. So as they're in parallel, we're going to do 1 over their total resistor, and since it's resistor 1 and resistor 2, 3, I'm going to call that resistor 1, 2, 3. So that's going to be 1 over resistor 1, which is 20 ohms, plus 1 over resistor 2, 3, which is 5 ohms. Let's see, do 20 and 4. So this gets me 5/20 is 1 over resistor 1, 2, 3. 5/20 is the same as, let's see, this reduces to 1/4. So then I can see resistor 1, 2, 3 must be 4 ohms. So now I get resistor 1, 2, 3 is 4 ohms. And I'm going to put that in the table. So resistor 1, 2, 3 is 4 ohms. And this is our total resistance. So then I could redraw the circuit and end up with the battery and one single 4 ohm resistor. And these three all together is the same as this circuit, or equivalent to this circuit. So let's see, if this is the total resistance, it's going to get the total voltage, which is from the battery, which is 12 volts. So putting that in my table, I know my 4 ohm total resistor here also gets 12 volts. Okay, so now we've done part A. We've calculated the total resistance, which is right here. That's 4 ohms. Next, we need the current through each resistor and the voltage through each resistor. So let's see, what do we know? I know using this, I could calculate total current if I wanted. Using this, I could calculate current through the 5 ohm. Where'd the 5 ohm, that's resistor 2, 3. Ooh. The current through resistor 2, 3, because resistor 2 and resistor 3 were in series, the current through resistor 2 is the same as the current through resistor 3, and it's the same as their total. So whatever number I can get for here, the current through resistor 5, or resistor 2, 3 in this case, is the same as the current through resistor 2 and the current through resistor 3 because they're all in series. Ooh, and if I know the voltage and the resistance, I can get that current. So I know voltage is current times resistance, or current, more importantly, is voltage divided by resistance. I'm going to get the current for resistor 2,3 because I know the voltage across resistor 2,3 is 12 volts. So the total resistance here is 12 volts. The total voltage is 12 volts. Total resistance is 5 ohms. So 12 divided by 5 is gonna get me 2.4 amps. So here, I know through this resistor, it's getting 2.4 amps. So this is 2.4 amps. But I also know this resistor is really these two resistors put together. So if this resistor has 2.4 amps, these two resistors are also getting 2.4 amps. So I now know these are both 2.4 amps. Oh, nice. And then once we know the resistance and the current, we can solve for voltage, because I know voltage is current times resistance. So solving for these voltages, I've got voltage is equal to I times R. And so if we're looking at our 2 ohm resistor, the current through the 2 ohm, we just found that was 2.4 amps. And the resistance of the 2 ohm is 2 ohms. So then the voltage through the 2 ohm resistor ends up being 4.8 volts. If we do the same thing for the 3 ohm resistor, so again we know the current through the 3 ohm, but the resistance of the 3 ohm is now 3, we would get the voltage of the 3 ohm resistor is 7.2 volts. So now we know up here the voltage for the 2 ohm is 4.8 volts. Voltage for the 3 ohm is 7.2 volts. And if we add this up, we get 12 volts, which is not a coincidence. These, if it's 12 volts across here, it's 12 volts across here, which means these two are sharing those 12 volts. And then we need one more thing to finish this off. We still need the current through the 20 ohm resistor, but we know the resistance and we know the voltage, so we could get that current. So figuring out that current, I know current is voltage divided by resistance, and we know our voltage is 12 volts, our resistance is 20 ohms, so that current going through there ends up being 0.6 amps. So 0.6 amps. So looking at this then, we have 0.6 amps of current going through here. That's very little current compared to the current going through here, which is 2.4 amps. I'm not surprised though, because this is a huge resistor, whereas this is an overall 5 ohm resistant branch. So this branch is easier to get through, so more current will go through it. And then, if we look at this, this is 0.6 amps going down this branch, and down this branch we have 2.4 amps. So that means total coming out of the battery, we must have had 2.4 plus 0.6, or 3 amps of current. And if we go back to our total battery picture here, I know current is voltage, so 12 volts, divided by resistance, 4 ohms, and our total current is indeed 3 amps. So there's 3 amps flowing out of the battery, and that's exactly what we figured out over here.